So this is our first lesson here in Unit 8-9, which is all about analyzing quadratics. And what we're looking at today is we are graphing standard form quadratics. So what we want to be able to do by the end of the day is sketch the graphs of functions that are in the form y equals ax squared plus bx plus c. And we know that this is the standard form for a quadratic equation. Now, we are going to do this by finding the x-intercepts, the axis of symmetry, the vertex, the y-intercept, and the symmetric points. And we're going to put all of these on our graph, and then we're going to draw our parabola. Now, we have encountered all of these things before back in Unit 4.5, so we're going to have a quick little recap of what all of these parts are. Because back in Unit 4.5, what we were doing was we had a graph, and we were figuring out what all of these things were from the graph. In this section, we're going the other way around. We're going to find all of these things algebraically, and then we're going to use them to draw the graph. So our graph, we know, is going to look like this. It is going to be a parabola, and we know that parabolas have a bunch of different features. So let's just refresh our memory on what all of these features are. We're going to start down here at the bottom with this one labeled number 1 here. That, of course, is our vertex. And we know it's our vertex because this is where our parabola is turning around and going in the opposite direction. Number 2, up at the top there, this dotted line that runs through the middle is our axis of symmetry. It divides our parabola in half so that the two sides are symmetric to one another. Number 3 over here at the right is our x-intercept. We know that this is our x-intercept because this is where our parabola is crossing the x-axis. Number 4 down here at the bottom is our y-intercept because this is where our parabola is crossing our y-axis. On the other side, number 5 here is the symmetric point, and we should specify that it's the symmetric point to the y-intercept. Our axis of symmetry divides our parabola in half, so the two halves are symmetric. So if we've got a y-intercept here, we have to have another point that is the same distance from the axis of symmetry at the same height. And of course, our last thing over here, number 6, is another x-intercept, because again, at this point, our graph is crossing the x-axis. And of course, these two x-intercepts are also symmetric points. So I could have labeled this one as a symmetric point as well. It's symmetric to the other x-intercept. Back in 4.5, we also did questions like this, where we were given some information about the parabola, and then ask some questions about it. So here we are given a couple of points on our parabola. We're given 3, 4, which we know is our vertex because it's where our parabola is changing direction. And we're given 5, 0 here, which of course is one of our x-intercepts because we can see that this is where our parabola is crossing the x-axis. So what is the equation of the axis of symmetry? Well, they've drawn the axis of symmetry on here for us, this dotted line right down the middle, axis of symmetry. We know it's traveling through the vertex and that our vertex has the x-coordinate of 3. So our axis of symmetry is going to be x equals 3. What are the coordinates of the other x-intercept? Well, our other x-intercept is going to be this point over here. We know that it is symmetric with our first x-intercept. Let's say this is an x-intercept. We know that symmetric points both have to have the same y value. So that's going to have a y value of 0. We knew it had to have a y value of 0 anyways because it's an x-intercept and y is always equal to 0 for an x-intercept. How do we figure out the x-coordinate? Well, we know that if these are symmetric points, the distance away from the axis of symmetry has to be the same for both of these. So if our axis of symmetry is at 3, x equals 3, we know that the distance from one intercept to the axis of symmetry has to be 2. 3 to 5 is a distance of 2, which means this distance here has to be 2 as well. 3 minus 2 is going to give us 1. So the coordinates of our other x-intercept are going to be 1, 0. Okay. So we're going to use all of those relationships between the intercepts, the axis of symmetry, the vertex, we learned back in Unit 4 or 5. They're going to come in handy as we look at sketching the graphs of these standard form parabolas. So our first example here, we've got y equals x squared minus 2x minus 8. And we want to sketch the graph of this parabola by finding the x-intercepts, or the zeros, or the roots, whatever we want to call them. Then we're going to use them to find our axis of symmetry. We use the axis of symmetry to find our vertex, and so on and so on. So let's start with the x-intercepts. We know that the x-intercepts occur when y is equal to 0, when it crosses our y-axis. Our x-axis, sorry. So we're going to take our equation here, x squared minus 2x minus 8, and we're going to set y equal to 0. And then we are going to solve for x. Now, we're going to do this by factoring. This is a simple trinomial, so this is going to, we're going to have an x and an x. We need two numbers that multiply to negative 8 and add to negative 2. Those numbers are going to be negative 4 and positive 2. And so we know that our solutions here to this quadratic equation are going to be x equals negative 2 and x equals positive 4. So these are our two x-intercepts. If we want to write them as points, negative 2, 0, positive 4, 0, because y is 0 for both of them. So we could add these to our graph right away. We've got one here at negative 2, 1, 2, 3, 4, one here at positive 4. Now, if we were sketching our graph and we wanted to put on our axis of symmetry, we know that our two x-intercepts here are symmetric to each other. So they're the same distance away from our axis of symmetry. So our axis of symmetry has to go right down the middle between these two x-intercepts. Right? If we're reading this off the graph, we can see that that's going through x equals 1. But if we wanted to just algebraically find the point that was halfway between negative 2 and positive 4, we can just do negative 2 plus 4 divided by 2. That's going to be positive 2 divided by 2 equals 1. So our axis of symmetry is x equals negative 1, just as we can see from the graph. Next up, they ask us to find the vertex. Now, we know the vertex is going to be somewhere on this axis of symmetry. We don't know exactly where, but if it's somewhere on this axis of symmetry, it also has to have an x value of 1. Like we know this vertex is going to be 1 something. How do we find out what that something is? Well, that something is our y value. So if we know that x is equal to 1, we can just sub x equals 1 into our equation. Our equation is y equals x squared minus 2x minus 8. Let's sub in 1 for x, and let's use the equation to figure out what y is. It's going to be 1 minus 2 minus 8. That's going to be negative 9. So our vertex is 1, negative 9. So let's add that to our graph. 1, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, negative 9. Now we can add a few more points onto our graph here by finding the y-intercept and then a point that is symmetric to that y-intercept. Our y-intercept occurs when x is equal to 0. So just like we did for our vertex, we can take that x value and sub it into our equation. So x squared minus 2x minus 8. We're going to sub in x equals 0 here, and we can figure out what the y value is going to be for our y-intercept. 0 minus 8, negative 8. So as a coordinate, this is going to be 0, negative 8. So let's add that onto our graph here. 0, negative 8. Right there. A point that is symmetric to that is going to be the same y value. So it's got to have a y value of -8, and it's going to be on the opposite side of the x-axis. So we can put it on our graph right there, and then we can just read off the coordinates there. 1, 2, 2, -8 would be that symmetric point. So now that we have like 5 points on our graph here, it's pretty easy to draw a nice smooth curve through all of these points, and that would be the graph of our parabola. All right. So we factored to get our x-intercepts. We used our x-intercepts to get our axis of symmetry, which is halfway in between them. Once we knew our axis of symmetry, we could find the y-coordinate for our vertex because the x-coordinate was on the axis of symmetry. And then we could just sub in 0 to get our y-intercept. So let's do another one here that has a little bit of a trick to it, and then I'll give you one that you can try on your own, and then we'll be done. So sketch the graph of -2x squared plus 12x minus 18. We're going to start this one off exactly the same way. We are going to say that our x-intercepts occur where y is equal to 0. So we'll set y equal to 0, -2x squared plus 12x minus 18. And we're going to factor this. Now this one's a little bit trickier to factor. We want to first check for a common factor. I'm going to factor out a -2, leaving me with x squared minus 6x plus 9. And then in brackets, we have a trinomial that we can factor. It's a simple trinomial. So we'll have x and x right there. And then we need two numbers that multiply to +9 and add to -6. Those are going to be -3 and -3. So when we go to get our solutions here, we're going to have x equals +3, but this one also gives us x equals +3. So we have only one x-intercept. And that's going to be at 3, 0. So let's put that on our graph here. Now, this gives us a little bit of a problem because we knew that our axis of symmetry was halfway in between our two x-intercepts. What if we only have one x-intercept? Well, if we only have one x-intercept, that x-intercept is going to be the vertex of our parabola. Like our parabola is either going to do something like this or something like this, okay, where it heads towards that one point, just touches the x-axis, and then it turns around and it goes the other way. So in this example here, we're going to jump over the axis of symmetry, and we're going to say that our vertex is 3, 0. Okay? And we can write a little note here that says it's the same as the x-intercept if there's one x-intercept. Now that we know that this is our vertex, 3, 0, we can draw in our axis of symmetry because we know that our axis of symmetry has to go through that vertex. So there's our axis of symmetry. And similarly, we know what the equation is going to be. It's going to be x equals 3. Okay, so we need some more points in order to be able to draw our graph here. We can do the y-intercept the same way we did it in the last question. We know that our y-intercept is going to have an x value that is equal to 0. So we can just sub that x value into our equation. Y equals -2x squared plus 12x minus 18. We'll sub in 0 and 0 and get our y value. 0 plus 0 minus 18. So y equals -18. So our y-intercept is going to be the point 0, -18. So to fit this onto our graph, I'm just going to use a scale here so that each box in the y direction represents 2. So 2, 4, 6, 8, 10, 12, 14, 16, negative 18 would be right there. And I'm going to label this as 0, negative 18. And that's going to be our y-intercept. Our symmetric point is also going to have a y-coordinate of negative 18, but it's going to be on the opposite side of our axis of symmetry. So it's going to be at 1, 2, 3, 4, 5, 6, negative 18. And there we are. That's our parabola. And we can draw a nice smooth curve through those 3 points that we have. Okay, so here is one for you guys to try. You might want to pause the video, sketch the graph of this parabola here, then start the video again just to check and see how you did here. We're going to follow the exact same steps that we did for the previous one. So we'll start by doing our x-intercepts. We are going to set y equal to 0. So 0 is going to be equal to 2x squared. X squared minus 2x minus 3. This is a simple trinomial. We're going to factor this as x 3 and 3. Oh, plus 1 and 3. So our intercepts are at x equals negative 1 and x equals positive 3. Right there. Our axis of symmetry is going to be halfway in between them. Negative 1 plus 3 divided by 2 is going to be 2 divided by 2 is 1. So our axis of symmetry is x equals 1. We should label this as our x-intercepts. We're going to label this as our axis of symmetry. We can do our vertex next. We know our vertex is going to have x equals 1. Y is going to be 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3, negative 4. So that is going to be the point 1, negative 4. It's going to be our vertex. 1, 2, 3, 4. There's our vertex right there. Our y-intercept is going to have an x value that's equal to 0. So we're going to sub in 0 for x, 0 minus 3. We're going to get y equals negative 3. So our y-intercept is the point 0, negative 3. 1, 2, 3, which is right there. Our symmetric point is going to have a y value of negative 3, just like our y-intercept, but it's going to be 1 square on the opposite side, so it's going to be at positive 2. Right there, 2, negative 3. And with those points, we can draw a nice smooth curve through our parabola. And there is our graph.